Today we're going to start talking about the definitions of acids and bases. There are multiple definitions of acids and bases. The two that we're going to talk about this year in chemistry are number one, Arrhenius, acids and bases, and then the second one, which will come in following days, will be Bronsted-Lowry. First one that we're going to talk about is called an Arrhenius acid or base. And the Arrhenius acid or base, Arrhenius acids, increase hydrogen ion concentration in solution. Okay, so what does that actually mean? So let's take hydrochloric acid and let's have a beaker of water. And here's our water, and we put the hydrochloric acid in there. And the first thing that it's going to do is it's going to break apart into H plus and Cl negative. And when they break apart into their parts, that's called dissociation. Dissociation means to break apart. And what happens is that it simply broke into its ion form, H plus and Cl negative. So let's put that in somewhat of a chemical reaction form. And it breaks into H plus and Cl negative. Now, here's the problem. This H plus that you see right here, this H plus is extremely unstable and it's setting in water. So we have some water molecules that are around. And guess what? The water is so stable that it will accept this hydrogen and it's going to make a brand new molecule. And that brand new molecule, after we have our water molecule, it's going to make a brand new molecule called hydronium. H3O plus. This hydronium, that is the acid right there. That hydronium, that is the acid. It doesn't actually exist as just an H plus floating around, but if you see it written as just an H plus, I will accept that as the acid. Here's the reaction that actually takes place. So we have HCl plus water yields H3 plus and Cl negative. So I will accept this as the acid breaking apart, or I will accept, I don't see it here, I will accept this equation right here. I'll take either one of those. I'll take the one that I circled there, or I will take this one that's underlined here. But you put the acid into water, and you can tell that it's going to increase hydrogen ion concentration in solution, therefore it's Arrhenius acid. The H plus doesn't stay as H plus. It actually joins with water to make H3O plus hydronium. And that is the chemical reaction that I want you to know. Well, if acids increase hydrogen ion concentration in solution, let's see what bases do. Bases increase OH ions in solution. And you guys remember that OH has a name, it's called hydroxide. And that was one of our polyatomic ions. Or you'll see it referred to as hydroxyl, but it's a hydroxide ion. So any solution that increases hydroxide ions in solution is considered a base. Let's look at one of the basic bases that you guys use in lab a lot, and we use sodium hydroxide. So if you put sodium hydroxide in solution, remember, here's our beaker, and you put it in. What's it going to do? It's going to break into Na plus and OH negative. And what's that called when they break apart? Dissociation. They dissociate, so they break apart. And this one doesn't react with water. They're both stable enough. Na plus. Here, let me back up. The Na OH breaks apart when you put it into water as Na plus and OH negative. Now, you will see when people write both the acid and the base equation, they will put AQ for aqueous. You guys remember aqueous? That just simply means that it's in a solution. So the two definitions that you have to remember for acids, anything that increases a hydrogen ion in solution is an acid. Anything that increases a hydroxide ion in solution is considered a base. Remember, you need to know these equations. You need to know that right there. And you need to know one of these two or both. This underline statement I have here, or this circle one I have here. Those two are saying the same thing. But remember, what is the acid? Well, it's the H. And the H joins with water to make hydronium. So you can either say the H plus is the acid or the hydronium is the acid. Both are correct. And one last thing before I sign off here is that I want you to notice something. Notice that all of the acids that we've talked about so far, like HCl, or I guess we haven't talked about any other acids, but let's say something like, here's just an example. How about something like H2SO4, right? What do you notice about those two? They're both acids and they both start with H. That's an acid. What are the bases? What can you notice about the base? Well, check this out. Anything that ends in OH is going to be an Arrhenius base. So we could have something like LiOH. That's a base. And then finally, if it is an ionic compound and it doesn't start with H and it doesn't end in OH, we're going to consider those salts. So something like NaCl. That's an ionic bond. Remember, it starts with a metal, ends with a non-metal, and it doesn't start with H, and it doesn't end in an OH. We call that a salt. This is actually table salt, but it could be anything. It could be, how about LiCl? Well, that would be another salt. It's a ionic compound. It doesn't start with H, and it doesn't end in OH. Therefore, it's a salt. So now you know the difference between an Arrhenius acid an Arrhenius base, and a salt. Next video, we will talk about Bronsted-Lowry acids and bases, and I will see you next time.